Have you ever lost marks on a chemistry question and had absolutely no idea why? Well, today we're going to solve a common mystery that trips up thousands of students. It's all about what's happening around that little arrow in a chemical equation. So let's get into it. So what's with this number, 45%? That's how many students make this one critical but super simple mistake when they see an equation like the one we're about to look at. Almost half. Let's break down exactly what's going on here.
So the question was simple enough, right? What are the reactants? And a student's answer, well, it seemed pretty logical. Potassium chlorate, manganese dioxide, and heat.
And bam, with that one answer, 3 marks were just gone, just like that. But why was it wrong? I mean, everything listed seems to be part of the starting process, doesn't it?
You know, this exact mistake trips up nearly half of all WAEC candidates every single year. So what really went wrong? And more importantly, how do you make sure this never ever happens to you? Don't worry, we're gonna fix this confusion once and for all.
The solution is actually surprisingly simple. It all comes down to one core idea I like to call the arrow rule, and trust me, it's gonna change how you look at every chemical equation from now on.
Okay, here's the rule, and it's a big one. Only the substances that actually change their chemical identity during the reaction are considered reactants or products. Everything else you see, the symbols above or below the arrow, the little letters in parentheses, that's all just context. It's the how or the where, not the what.
I want you to think of the arrow as a finish line in a race of transformation. If a substance starts on one side and ends up as something completely new on the other, it has officially crossed the arrow and it's part of the reaction.
But if it's just kind of hovering above or below the arrow or just describing the state of a substance, it's like a coach on the sidelines or a commentator at a game. It's helping the reaction happen for sure, but it's not actually in the race itself.
So to make sure you never get this wrong again, I've got a foolproof 3-question method you can apply every single time. Think of it as your new mental checklist. First, you're gonna ask yourself, what did I start with? Just look to the left of the arrow, those are your reactants. Second, what new things did I end up with? Look to the right, those are your products. And finally, the most important question, what helped the reaction happen? Anything written on or near the arrow itself is a condition. It's the secret ingredient or the environment needed for the change, but it's not a reactant or a product. So let's get our key terms straight. Reactants are your starting materials, products are your final substances, and catalysts, well, they're the facilitators. They just speed things up without getting used up in the process, which is exactly why they are never reactants. All right, let's walk through a real example together, and we'll apply our 3 questions step by step. Okay, let's apply our method. Question 1, what's on the left of the arrow? We've got nitrogen, N2, and hydrogen, H2. So those are our reactants, simple as that. Question 2, what's on the right? Only ammonia, NH3, that's our product. And now for the crucial 3rd question. What's on the arrow? We see an iron catalyst, a high temperature, and high pressure. These are the conditions, the how. They are not reactants. And that little G, that just tells us the state of matter. It's a gas. It's just extra info, not a substance. See? When you break it down like this, the confusion just melts away. Now, let's look at a special case that often causes some confusion. Catalysts. How they're written in an equation makes all the difference in the world. Let's compare 2 examples. So on the left, in equation A, the manganese dioxide is correctly shown above the arrow. This clearly marks it as a condition, a catalyst. But look at equation B. Here, it's listed as a reactant and as a product. Since it shows up on both sides completely unchanged, it hasn't actually been transformed. It's a bit of a confusing way to write it, but it shows the same thing. It's a catalyst, not a true reactant. So which one is written more clearly? Oh, definitely equation A. Placing the catalyst above the arrow makes it crystal clear that it's just a condition of the reaction, not a participant that gets changed. All right, now it's your turn. Let's see if you can apply what you've learned to a brand new equation. Take a second and try applying the 3-question method to this equation. Go ahead and identify the reactants, the products, and the conditions. We'll go over the answer in just a moment. Okay, let's break it down. On the left, we only have calcium carbonate, CaCO₃, so that's our reactant. On the right, we have 2 new substances, calcium oxide and carbon dioxide. Those are our products. And that little delta symbol on the arrow, that's just a shortcut for heat is applied. It's a condition, not a reactant.
If you got that right, you've officially mastered the arrow rule.
So what does this all mean for you? It means you've just unlocked a whole new level of confidence for reading any chemical equation that gets thrown your way. You can now look at any equation, no matter how cluttered or crazy it seems, and confidently pick out what's actually reacting and what's being formed. You know the secret now. Only what chemically changes by crossing the arrow truly counts. Everything else is just part of the story.
Just remember that rule, and you'll never lose marks on this kind of question again. You've totally got this. And hey, if this explainer cleared things up for you, think about sharing it with a friend who might find it useful too. Thanks for watching.